Welcome to Chibuzor Math Physics. In this video, we shall be looking at uniform circular motion. What actually is a uniform circular motion? When we say that we are talking about uniform circular motion, we are simply referring to an object, the motion of an object in a circle at a constant speed. So the motion of an object in a constant speed is what we call the uniform circular motion. Before us is a question that we are to find the maximum tension on the string that can withstand without breaking. And here we have a question that a light inextensible string of light is fixed at its upper end and support a mass at the other end, and this is rotated at horizontal plane or radius, as will be indicated shortly. So the maximum tension the string can withstand without breaking is 2 newtons. Assuming that the string breaks when the radius is maximum, we are to calculate the velocity of the mass when the string breaks, given that L, which is the length, is 1.25 meters and M, which is the mass, is 0.1 kg. So let us see the solution to this problem. We know that tension is given by T equal to F, and F will be equals to mv squared by R, which is the radius. Here we know that F is given the force to be 2 Newton, because we are told that the maximum tension the string can withstand without breaking is 2 newtons. And we know that the tension is equals to force, and force is equals to this. So this implies that tension, which is force, is 2, and 2 will be equals to mv. We are looking for the velocity of the mass, so v is not given, but m, we know m is 0.1 meters. If m is 0.1 meters, we simply have 0.1 multiplied by v squared, since v is not given, divided by the length, which is 1.25 meters. This will give us, we are looking for velocity of the mass when the string breaks. So this will imply that v squared will be 2 multiplied by 1.25 divided by 0.1, or you just simply cross multiply so that we make v squared the subject. So put this in your calculator, you will have v to be equal to 5 meters per second. Pause the video and try doing it yourself. Of course, we know that 2 multiplied by 1.25 divided by 0.1 will simply give us, this is 25, but we have v squared. So to remove the square root, you square both sides. So the square root, if we put the square both sides, this will become v, assuming that this is square, so that we remove the square root. And if we square 25 here, we will simply get 5. That's why the answer is 5 meters per second, just for clarity. And this is our solution. Let us look at the second question. It says that the diagram below shows a mass. So first of all, let me have the diagram. The diagram shows a mass which is rotated in a vertical circle. So there should be a vertical circle. So let's have a circle. Just use that. Okay. The speed of the mass is gradually increase until the string breaks. The string breaks when the mass is at its lowest position A and at a speed of 30 meter per second. Point A in 5 meter above the ground. So 5 meter above the ground. This is to say that 5 meter above the ground is here. 5 meter. This is one. This is ground. So we are to calculate. We are to show on the diagram we have shown. This is 5 meters and this is ground. This is the ground. This shows the direction RM1. So after showing, we are to find the initial direction of the mass at the point the string break. At the point the string break. Okay, assuming that it is this way, let's assume we have something like this. The string break, this is 5. This direction. To answer question B, we are going to use one of the equations of motion. S is equals to ut plus a half at squared, because it seems that's what we have. So that t will be given by the roots of 2 by 5 divided by 10, because we are told that 5 its point is 5 meter above the ground, so we need to divide by 10 so that we are able to get that. This will give us 1 second. That will give us 1 second. Here it says that the path of the mass from A until it strikes the ground. The path of mass from this position until it strikes the ground. So we have to calculate the path of mass from here until it strikes the ground. So to do that, we simply need to, this is B, we use S to be equals to UT, which is equals to, we have 30 meters, because the position A and at a speed of 30 meters per second. So we are going to say 30 multiplied by 1, which is simply 30 meters. And this is the solution for the second option. The third one says that we are to calculate the initial time it takes to reach the ground after breaking off. The initial time it takes to reach the ground after breaking off. So this will simply be v squared is equals to u squared plus 2as, should be the fourth or third equation of motion. Plugging in what we have, we will simply have the square root of 2 by 10 by 5. which is going to give us 10 meters. And that's how we deal with circular motions, problems that involve circular motion. In the next video, I will be taking you through principle of conical pendulum, or what we call the principle of circular motion. And inside that principle, I will introduce centripetal acceleration of bucket, as they are equal or higher than the gravitational acceleration of the water. Stay tuned and enjoy the next video. Hope you have enjoyed this video, and if you are new to this channel, don't forget to click on the subscribe button so that you'll be notified as we upload the subsequent videos. Kala guys, God bless you.